Okay, so let's solve this question. The question is basically giving us a C program and it is asking us the value that it is going to be printed, right? And it is a numerical value that we have to give, right? So this main function from which the execution of the program will start is quite straightforward. We are defining an array and these are the elements of the array. Now you may have studied and remember that when you are defining an array in C, then you must give the number of terms in the array at the starting. But as the number of terms is not present over here, you may think that this is going to give a compilation error, but that is not true. In C, if the exact value of the array is provided as is present over here, then the compiler basically interprets the size from the given value, right? And total number of elements over here are basically 9, right? 3 sets of 3 elements, right? So this compiler is going to automatically produce a 9 over here, and from that the compilation is going to go on without any problem, right? That is one thing, and after that the printf over here takes percentage d. This is a format specifier which is used for integer types, right? There are different format specifiers. Obviously percentage s is for strings, percentage c is for character. Basic small amount of revision for the things that you must have studied, right? So this percentage d is going to print the value that the function foo is going to return. As can be seen from the declaration of foo, the foo returns a function int, right? So it returns an integer and that integer is basically printed, right? Not very complex. Now see, this is a kind of thing that you must understand over here, is that foo is taking the value of a, which is an array, and 9, right? And right over here, if you can see the input, right, these two parameters that are written inside of your function declaration, these are called formal parameters, right? These are your formal parameters, and these values that are actually fed to the function are actual parameters, right? Normally actual parameters and formal parameters, the interpretation is not quite different. If integer is passed and then an integer is received, there is no difference in that. But obviously when an array is passed now, then there is a difference over there. What difference? You may say that for instance, that over here if I were to be printing the size of a, right, there is an operator in C known as size of. If I were to produce the size of a, right, inside of this main block, then it is going to give me the answer of this size of a is going to give me 9 number of elements, and every element is an integer, so it is 9 cross 4, it is equals to 36, it is going to give me, right? But if I were to do the same thing, printing the size of inside of foo of s, right, if I were to print over here the size of s, this thing is going to give me an 8. Why? Because s is interpreted as a pointer. When an array is sent, right, it is received as a pointer, right? So this s, if these brackets were not present and a star was present over here, that would have been equivalent, right? Now this is a concept that as practice goes on you will understand, but I will give a demonstration of this so that you have better understanding, right? So this is a kind of sample code in which this is your values are present from 1 till 9. So this array has 9 elements, so its size is 9, right? So I'm sending this array, right? The actual argument is sent and the formal argument is received in the same format, the same kind of syntax with braces over here as is present in our question. Then I print the value of the size of b, right? This is giving some warning but not an error, right? So this size of is going to be printed over here, and then once this b's value has been printed, its size has been printed, then I'm going to print the size of a, right? And I've actually run it before also, but I will going to run it one more time, right? So when the control goes through foo a, it basically prints 8. Why? Because b is interpreted as a pointer, and when it goes through this part, it prints 36 as I basically explained, right? Very simple. Now if I were to replace these braces with a star behind it, right, that is a pointer definition, it is going to print exactly the same thing. So these square brackets present over here may be misleading to those who have not been exposed to this kind of interpretation of the syntax in the C language, right? So once that kind of wrong understanding has been dispelled, now let's move forward and try to understand how the code is going to operate from now on, right? So let me just erase the excess part so that we can focus on the main part. Too much excess of information sometimes is not convenient or productive, right? So you must keep it very on the point, right? So this foo basically goes over here, right? So at any, and just one more thing, foo is a recursive function. It calls itself over here also and over here also, right? And recursive functions are kind of very difficult to explain, right? After doing programming, slowly and slowly you develop the kind of grasp exactly how you have to interpret it. But if you have not really been exposed to that, it is kind of difficult for you to understand recursive functions. The best way to understand recursive functions is to follow along the logic of the recursion that is actually happening, right? And you can do that by yourself also, but I am going to do it right now so that you have very clear understanding of what exactly the question demands, right? So let's follow along the logic, right? We as humans can perceive patterns and possibilities. If you follow along the numbers and see, as they change and manipulated by the code, then you're going to basically understand the kind of nature the code has. And once you have the natural understanding of the code, you can basically parse through the data with that understanding and get to an answer without actually going on throughout basically following along the code like a computer, but actually applying some kind of brain and then analyzing the input and then getting to answer from an analytical point of view, right? So that is an objective, because following along the whole logic like a computer, you will also get the answer, but that is not the objective. The objective is from that you use your human superpower, that is your pattern comprehension capacity. That is kind of the main point of doing this kind of thing. So let's pay attention and we will be able to do it very simply, right? So at every single instance, if you were to look closely, we are basically doing s plus 1 over here, s plus 1 over here, when we are again calling foo, right? So if at any given instance the foo had this 0 as its s, if I were to pass s plus 1 over here, it's a pointer, right? So from 0 it is going to point to the next one, right? Like this, like this, like this, right? It's going to move downwards as the recursion progresses, right? So it is kind of thing that we have to go through to get to answers, right? So let's do that, right? For the first call that we have over here, right? For the first call that we have over here, we are basically going inside with this foo being equal to 0, right? Because the s right now points to 0, right? And because s points to 0, s of 0 is going to point to 0, and s of 1 is going to point to its next element, that is 1, right over here. I do hope that this part is very clear, right? If for instance this foo were to be pointing to, suppose, say 2, then the s plus 1 is going to point to, no, this is not a good example. If foo were to be pointing to this 2, then f of s plus 1 is going to point to this 0, right? And likewise, and so on and so forth, right? Very simple. Now let's follow along the code. The first execution right over here, we have the size is equals to 9, right? We go through here, size is not equal to 0, size is not equal to 1, so we come over here. Is s0 is equals to not equals to s1, right over here? Is that true? Yes, s0 is pointing to 0 and s1 is pointing to 1, and both of these are not really equal. So this code segment is going to be executed, right? When this code segment executes, then this part is stored in the stack and the new function is called, which is the second part, this foo, with s plus 1 and size being reduced to 1, right? So this expression, after this, the return part over here is going to return the control from this original foo, right? So the rest of the code of this foo is now irrelevant for this particular execution. The next execution is going to start with foo being moved to 1. That part is very clear, but the current code, this return or any part of this function is not going to be called with foo basically being 0, right? So this plus 1 can be independently written as part of the answer that we're going to get, right? So let's write that. So answer is can be written as 1 plus, and this is a blank that we're going to fill, right? And foo, now foo points to 1, right? And size has been reduced. Size has been reduced till 8. Very good. Now we're going to come to this one more time, and again size is not equal to 0 or 1, so these two are not going to be executed. After that, is s of 0, that is 1, is not equals to 2? Is that the case? Yes, it is the case. So again we are going to basically execute this part. So it is going to get 1 plus, and then another blank for the foo that has been called, right? And then with this foo being called, this f is moved one more time till pointing this to this 8 has been made into 7, and we come over here again. Both of these are not going to be executed because size is not equals to 1 or 0. Now s of 0 is equals to s of 1, right? So both of these are basically same. So this part, they being different, is not really true. So this if segment is not going to be executed. The control is going to get till this command, right? It is basically directly calling foo and not doing this plus 1, right? So over here in the answer, another plus 1 is not going to get included, right? After that, so this foo is moved here. Then again these some exact same instance, right? The next element is exactly the same. So there is nothing going to be added to the answer over here. Then we move here. Now a plus 1 is going to be added. I do hope after all this iteration you must be able to follow that at every difference a 1 is added, and at every similarity nothing is added, right? So with that being present, as we came to 2, another plus is going to be added, 1 plus and then another blank, right? Then this foo is moved to 0, nothing is going to be added, it is moved to 0 again. Now 1 is going to be added over here, plus 1 plus, right? And then we move this foo to 1, nothing is going to be added at foo, and then we move foo to 1, right? One more time, as the next element was similar to this one. So this if segment was not executed, right? And when we came to this one, right, at this point, because size was reduced at every single instance like this and so on and so forth, and this is the last element. This is the last element at which the whole thing has been reduced, right? So it is going to become 1 basically. And how it is going to become 1? Because for 0 it was 9, for 1 it was 8, and there are total of 9 elements, right? So right now we have gone at the second element, it has become minus 1, right? The second element it has become minus 1, right? So at the ninth element, right, for second element, 9 minus 2 plus 1 was the current value, right? And that was 8, right? For the ninth element, it is going to become 9 minus 9 plus 1. So it is going to become 1, right? It's kind of, you can follow along at every single, you can write 9 for this, 8 for this, 7, 9, 8, 7, 6, 5, 4, 3, 2, 1, right? So for 1, it is going to be, size is going to be 1, right? And when size is equals to 1, now this if segment is activated, and the return part gives 1 directly. It does not really calls anything. So at this point, the final blank over here is going to be replaced with a 1, right? And I have followed along and produced all the ones already. So another 1 is added at the end. And what is the sum of all this? There are total number of 5 ones, right? So the answer for this question is going to be 5, right? Pretty straightforward. And I do hope that you must have been able to solve this question by yourself, and I only provided a kind of validation to your solution that you got independently. And that, have a very nice day, and I will see you in the next video.